In this video, we're going to look at a distance problem. Number 3 says, at noon, a van passes a landmark. 10 minutes or 1/6 of an hour later, the car, heading in the same direction, passes the same landmark. The van is traveling at 30 miles per hour, the car at 45 miles per hour. At what time will the car catch the van? And they give us a picture as a visual. So the first thing they want us to do is choose a variable to represent the unknown. And the unknown is time. We want to know how much time it will take the car to catch the van. So t is equal to time the van is traveling The second question asks, what is the same for both the van and the car? Is it distance, rate, or time? And the thing that is the same is they're traveling the same amount of distance from the landmark to when the car catches the van. So we're going to say they both travel the same distance. And now we want to fill in our chart with the information. So the rate of the van, they told us, was 30 miles per hour. And the rate of the car is 45 miles per hour. And we said that the van travels time t, and the car left 10 minutes or 1/6 of an hour later. So the car's time is t minus 1/6 because our formulas are in hours. And now we want to create some distance functions. So we have distance for the van is equal to rate of 30 times t for time, and the distance for the car is equal to 45 times t minus 1/6. And now it asks us, how are the distances related? And the distances are equal. So the distance for the van is equal to the distance of the car. And now they want us to write the equation modeling the problem. So we're going to have 30t equal to 45 times t minus 1/6. And the first thing I'm going to do to solve the equation is distribute the 45 through the parentheses. So I have 30t is equal to 45 times t, 45t, and minus 45 times 1/6 is 7.5. And now I'm going to subtract 30t from both sides and add 7.5 to both sides. So I get 15t is equal to 7.5. And now we're going to divide both sides by 15, and we get t is equal to 1/2. So it takes a half hour of the van traveling for the car to catch them. And then if we want to find out how much time it took the car, we could say that it was modeled by t minus 1/6, or 1/2, which I could write as 3/6 minus 1/6, which is equal to 2/6 or 1/3. So it takes the car 1/3 of an hour to catch the van. And now it wants us to check. If we wanted to know the total distance that the car and the van traveled before the car caught the van, we could say that the distance of the van is equal to 30 times t, which was 1/2. So it's 15 miles. So both the car and the van traveled 15 miles before the car caught the van. So now in order to check, I'm going to take the amount of time that each traveled times its rate and see if I get 15 for both of them. And we did the van up top. They went 30 miles times 1/2 is equal to 15. And then the distance for the car is equal to 45 times 1/3, which is equal to 15. So both of them traveled 15 miles, so we have the same distance. And now we want to state the answer. So we can say that the car caught the van a half hour after they passed the landmark, and the van passed the landmark at noon. So we can say that the car caught the van at 12:30 p.m. And that's all for this video on the distance problem, example 3.